Welcome my dear students to a very interesting session in Parabola. We are having some very important results we are going to discuss, right? So these things, so suppose we are having when the origin is shifted to a point h comma k. Now for this parabola y minus k whole square is equal to 4a times of x minus h. Right, for this parabola the equation of the normal is actually it is y equal to mx minus 2am minus am cube. Now in the place of y we are replacing by y minus k and x by x minus h. Now y minus k equal to m into x minus h minus 2am minus am cube. Right, this is what the equation of the normal, right, and this is the parabola. And in the same way now we are having the second type of parabola when origin is shifted to the point h comma k. Now we are having the another parabola, that is minus 4a times of x minus h, like this. Y minus k whole square equal to minus 4a times of x minus h. For this the equation of the normal, just you replace y by y minus k and x by x minus h, that is nothing but m into x minus h plus 2am plus am cube, like this, plus 2am plus am cube. That is what now the equation of the normal, right? Fine. Now the third one what you are having is, right, the parabola is x minus h whole square. This is equal to x minus h whole square is equal to 4a times of y minus k, right, my dear students? This is what the third upward parabola when origin is shifted to the point h comma k, like this. Then what we are having is the equation of the normal is nothing but x minus h is equal to m times of y minus k, m times of y minus k minus 2am minus am cube. Okay, my dear student, this is what equation of the normal for upward parabola when origin is shifted to the point h comma k, like this. Number 4, you have now h minus h whole square is equal to minus 4a times of y minus k, you are having like this. For this parabola, now the equation of the normal is nothing but x minus h is equal to m into y minus k plus 2am plus am cube, right? This is what equation of the normal for the fourth type of parabola, that is downward parabola with when origin is shifted to the point h comma k. Now see, this table totally summarizingly gives 4 parabolas when origin are shifted to the point h comma k and their equation of normals already we proved them, and in the place of y we are going to take y minus k and in the place of x we are going to take x minus h, right. Now we have one more important result. If the normal at the point p81 square comma 281 meets the parabola y square is equal to 4ax at 82 square comma 4a-t2, right, meets at 80t square comma 2a-t2, like this. This is 2a-t2, then t2 equal to minus t1 minus 2 by t1. This is what we require to prove, my dear students. You see, we are having the parabola for y square is equal to 4ax and equation of the normal in parametric form, right? The equation of the normal in parametric form is nothing but y plus, right? That is nothing but the equation of the normal in parametric form is y plus tx is equal to, right, y plus tx is equal to 2at plus at cube, 2at plus at cube, like this, right? This is what equation of the normal in parametric form already we proved. Just to refer your notes, my dear students. Now it passes through the point, right? Okay, if the normal at the point means what? Okay, that means this point is passing through the normal, right? The normal is passing through that point. Therefore, what you will get is y plus t1x is equal to 2at1 plus at1 cube. Okay, my dear students, you just write it as equation number 1. Now, this normal is passing through this point means it satisfies this equation. Now, it meets the parabola y square is equal to 4ax Okay, now this is a point on the parabola and the normal is also meeting at this particular point. That means this point also satisfies this normal equation. That means what you are going to get, y plus t2x is equal to 2at2 plus at2 cube, like this. at2 cube, like this. Now you have got equation 1 and equation 2, right? Fine. What we do is, right, once we have got that thing, right, it passes through at2 square comma 2at2, right? We have got like this. And also one more thing what we can do is nothing but, since this is passing through the one, okay, through this normal is passing through this point, even we can write it as something like this. What we can write is, see here, this is passing through the point at2 square comma 2at2, we are having like this. Now let us just substitute this point in this one. Y means what? 2at2 plus t1x. X means what? A into t2 square, like this. This is equal to, you are having 2at1 plus at1 cube, like this, right? at1 cube. Now what we do is nothing but, let us bring this to this side, from what we will be having 2a t2 minus t1, right? Once you transfer this to this side, then we will be getting 2a, okay, times of t2 minus t1 is equal to, what we are having is, right? Now see, my dear students, what we did is this, we transferred and we have taken that to the right side. Now we taken here, which one is common? Minus at1 is common. Minus at1 we have taken common. Now this becomes t2 square minus t1 square, right? Now this is equal to, you are having here this a will cancel, and also 2 into t2 minus t1 is equal to minus, right? This is now minus t1 times of t2 square minus t1 square is minus t2 into t1 and t2 plus t1, like this, right? This will cancel like this. Now 2 equal to minus t1 into t2 plus t1, right? Wonderful. Now we want to subject to t2, we need to prove this one like this, right? I think from this we try to get it. You see, my dear students, this is nothing but actually 2 by minus 2 by t1, okay, totally we transfer minus t1, that equal to t2 plus t1 we are having there. From that t2, if you subject, what we are going to get, right, minus t1 minus 2 by t1. If you subject to t2, we are getting like this. See how beautifully we have got this result, my dear students. If the normal at the point at1 square comma 2at1 meets the parabola at, then we need to prove this. This is what equation of parabola, this is what equation of normal. Since it passes through 2 points, we have taken this. And also one more thing, in this equation, okay, because this is the normal, it passes through the point. Which point? This point. Just substituted, simplified, and we have got this beautiful result, right? Now we have a nice result. 3 normals can be drawn from a point to a parabola. 3 normals can be drawn from a point to a parabola. My dear students, you see, it's a wonderful result. How we are going to do this one is, suppose in a diagrammatic way, if you check, suppose you are having like a parabola, suppose you take one point h comma k, like this, p h comma k. They are telling that 3 normals can be drawn from a point to a parabola like this. This is maybe one parabola. See, this may be one normal, you may have like that, right? And another normal you may find here like this, right? And another normal may be here like this. That means through one point only 3 normals can be, okay, 3 normals can be drawn from a point to a parabola. This is what we are getting like this. If this is what P. Now this is A, B, C are the foot of the perpendiculars, right? At these 3 points even you can draw the tangents. These are the feet of the normals. And these 3 points only you call as conormal points. Right, my dear students? Now the definition of conormal points are nothing but from any point if you draw the normals which meet the parabola at right angles. These are called the feet of the normals. Those only are called as conormal points. Now we got the definition of conormal points also. Right? This is the parabola we are having, my dear students. Y square is equal to 4ax. And the equation of the normal, you know that, right? We have already derived that equation of normal for this parabola is y is equal to mx minus 2am minus, right, minus 2am minus am cube, like this. 2am minus am cube. This is what equation of the normal, right? Y is equal to mx minus 2am minus am cube is what equation of the normal. Now this normal is passing through the point h comma k. Now this normal is passing through the point h comma k. Then what we are going to have is k is equal to mx, m into h minus 2am minus am cube. Like this we are having here. Right? Now, see, we are going to form this as something like it is a cubic equation we have got now. That is nothing but am cube you are having here. See, let us write these terms. So let us bring them here. This is now am cube, right, plus 2am minus mh plus k equal to 0. Let us transfer all these terms to the left side. Then you have got now a cubic equation wonderfully. And here m, if you take common, 2a minus h plus k is equal to 0. Wonderfully. Now this is a cubic equation you are having. This is a cubic equation means it is having 3 values of m. Corresponding to each value of m, there is a normal passing through the point h comma k. Hence, 3 normals can be drawn from a point to a parabola, right? Because it is we got it as a cubic equation. There are 3 values per m. For each m value, there will be one normal is passing. That's why there can be possible that 3 normals can be drawn from a point to a parabola. See how beautifully we have got this particular result. And I told you already the feet of the perpendiculars are called as conormal points, and we can maximum we can pass 3 normal from any point to a parabola. Now we have another result. If m1, m2, m3 are slopes of 3 normals. Now only we proved, my dear students, the previous result. Through one point we can pass through 3 normals to the parabola. And if m1, m2, m3 are the slopes of 3 normals, we need to prove m1 plus m2 plus m3 equal to 0. And m1, m2, the second one, m1, m2 plus m2, m3 plus m3, m1 equal to 2a minus h by a. Now the third one, m1 into m2 into m3 equal to, you have to prove, minus k by a, right? For this, see, my dear students, now only we have got a cubic equation. Okay, we have got what? A cubic equation. Okay, it gives actually 3 values of m, right? It is a cubic equation satisfying the normal equations. Now only we have got. Since okay, it is a cubic equation, it will have the roots as 3 things. m1, m2, m3 are the roots, right? These are the roots of equation number 1, like this. If m1, m2, m3 are the roots of equation number 1, right, my dear students, then sum of the roots, you know that m1 plus m2 plus m3 is nothing but minus x square coefficient divided by x cube coefficient, right, my dear student? This is the formula, right? This is now x square coefficient. Here you don't have x square coefficient, means here m square coefficient. Here x square means here what? The equation in terms of m. That's why minus m square coefficient divided by m cube coefficient. Here there is no m square coefficient. That's why it becomes 0. 0 by m cube coefficient is a. That means 0 you are having like this. m1 plus m2 plus m3 equal to 0. Okay. Next. Okay, we have in theory of equation the another concept. Okay, the sum of the roots taken two at a time, that is m1 m2 plus m2 m3 plus m3 m1, like this, m3 m1, this is equal to, right, what we are going to have is, okay, m coefficient like this and x coefficient. Actually in the place of x we are having here m, because this is a equation in m coefficient divided by m cube coefficient, like this, m cube coefficient. M coefficient is nothing but what? 2a minus h. 2a minus h divided by m cube coefficient is what? A. Then we have got the second result. See, beautifully we have got second result like this. And first result we have got also very nicely, right? Wonderful. Now the third one is you are having m1 into m2 into m3. Product of the three roots is nothing but minus of constant term, like this, constant term divided by x, okay, divided by x cube coefficient. X cube means here m cube coefficient, like this, m cube coefficient, like this. This is now minus of, okay, the constant term is what here? Minus k by a. Like that we have got nicely the third result also. Therefore, it's a very important result, my dear students. If m1 and m2, m3 are the slopes of three normals, then they satisfy this condition. How we have got? We already got it is a cubic equation. That means it will have the three roots as like this. Now, sum of the roots by this formula you are getting this, and sum of the roots taken whose product at a time, this is equal to 2a minus h by a. Now the third one, product of the roots, that equal to minus k by a, right? In this beautiful way we have got this result, and we can use this in many places. Now see, we have a sub result which is based on now what we did. The algebraic sum of the slopes of the normals at co-normal points is 0. That means we need to prove slopes of the normals, those are m1, if you take them as m1, m2, m3, right? Now only we proved that m1 plus m2 plus m3 as 0 as the first result. This is only the result they are asking here. Just for the reference purpose, once again I am repeating. Okay, the algebraic sum of the slopes of the normals at co-normal points is 0. That is what? m1 plus m2 plus m3 equal to 0. Already we have got it. That is once again I am mentioning here. Right? Now we have one more beautiful result. The sum of the ordinates. Ordinates means y coordinates of co-normal points. Co-normal points is 0. You know, my dear students, actually whenever I told you that we have a parabola like this, means from one point, suppose you take that h comma k, I told you that you can pass three normals. Already we proved that result like this and like this. Only three normals can be drawn. If you take this as a, that is something like a m1 square comma minus 2a, right, m1. These are the coordinates of this point a, right, a m1 square comma minus 2a m1, because we already derived how to get the point of contact. Now b is nothing but a m2 square comma minus 2a m2, like this, minus 2a m2, and c is nothing but a m3 square comma minus 2a m3, like this, right? These are the 3 feet of the normals and their points are these. Now they are asking their sum of their ordinates. Sum of their ordinates means what here? This is what? Minus 2a m1 is the first ordinate. Next minus 2a m2, right? We are adding them all these. And minus 2a m3. This we need to prove it as 0. That is very obvious, my dear student. Now if you take minus 2a common, this is now m1 plus m2 plus m3 you are having like this. Right? This is now minus 2a into 0, because we know already m1 plus m2 plus m3 as 0. That now equal to 0. Therefore we have got the result. The sum of the ordinates of the co-normal points. These are the co-normal points. Okay, their sum will be 0. See how beautifully we have got this result, right? Now we have another result number 7. The centroid of the triangle formed by the co-normal points on a parabola lies on its axis, right? You know, see my dear students, This is the parabola we are having that. I told you that if you have one point something like P, H, comma, K, I told you that, okay, you can pass through three normals, right, which are perpendicular. These only you call as conormal points like A, B, C, like this, right? And A equal to, now only we discussed that is A m1 square, comma, minus 2A m1, like this, right? A m1 square, comma, minus 2A m1, and B is nothing but, right, A m2 square, comma, minus 2A m2, like this, right? And C is nothing but what you are having, A m3 square, comma, minus 2A m3, like this, 2A m3, right? These are the things. Now the centroid is nothing but, you see, the centroid is nothing but, you know, A m1 square, you know, x1 plus x2 plus x3 by 3, comma, y1 plus y2 plus y3 by 3. Now this is what x1 is A m1 square plus A m2 square plus A m3 square, okay, whole by 3, comma, okay, this is what x1 plus x2 plus x3 by 3, comma, y1 plus y2 plus y3 by 3, that is minus 2A m1 minus 2A m2 minus 2A m3, right, whole by 3, like this you are having. Now this is what the centroid is equal to this, right? Now this you can write it as, this is equal to A into m1 square plus m2 square plus m3 square, like this, whole by 3, comma, minus 2A if you take common here, this is now m1 plus m2 plus m3 by 3, like this, right? Fine. Already we know that, right? This is now, my dear students, A into m1 square plus m2 square plus m3 square by 3, comma, this is 0. Already m1 plus m2 plus m3 as 0. Okay, now 0 into anything becomes 0. That means, you see, my dear students, the centroid is, okay, lying, okay, which lies on its axis, means, okay, this y coordinate becomes 0, y coordinate becomes 0, y equal to 0 means what? Okay, y equal to 0 means what? It is x-axis, like, right, x-axis, and it is what? The axis of its parabola, like, okay, here y coordinate equal to 0, y equal to 0 means it is equation of x-axis, therefore it is lying on it, right, which is lying on it, okay. This is what equation of x comma 0, some x value comma 0 means which lies on x-axis, and the x-axis is what? The axis of the parabola y square is equal to 4ax. Therefore we have proved nicely this result, okay. For this parabola the axis is nothing but x-axis, and we have what? X-axis means if any point lies on x-axis whose y coordinate becomes 0. That means we got the same thing only, the y coordinate becomes 0. Therefore it is lying on the axis of its parabola, y square is equal to 4ax, right? Hence the proof. Now, and another important result, now the concept is pair of tangents and their chord of contact. This is the heading, okay, pair of tangents and their chord of contact, right? This is what result number 8, my dear students. What is this result? Is prove that two tangents can be drawn from a point to a parabola, right? We need to prove that there are two tangents can be drawn from a point to a parabola, and the two tangents are real, and distinct, okay, are coincident, or imaginary according as the given point lies. If the point lies outside, then you will have two distinct tangents, right? Are coincident. If coincident means, okay, then the point will lie on the parabola. Imaginary means it is lying inside the parabola. This is what the result. Now see, my dear students, how we are going to do this particular one in detailed way, right? Suppose you see, my dear students, whenever you are having a tangent like this, right, and you are having a point P, H, comma, K, which is outside of it, right, like this. When it is outside, you can able to draw two tangents. When it is inside, you can just coincide the two tangents. If it is on the parabola, it can just coincide. If it is inside the parabola, you cannot draw at all the tangents. That is what the total summary of this statement like this. And my dear students, y is equal to mx plus a by m is what the equation of the tangent to the parabola in slope form. Now this tangent, these tangents are passing through this point h comma k. Then we will have k is equal to m into h plus a by m like this. Right, my dear students. Now what we do is, let us take LCM. K is equal to m square h plus a whole by m like this. Now do the cross multiplication. You will have m square h plus a, okay, minus km is equal to 0 like this. Now this is nothing but m square h minus mk plus a equal to 0. Now you have got wonderfully a quadratic equation in m. It means that it is having two tangents. We can able to draw two tangents from an external point to the conic. Okay, to the conic. Here the conic is a parabola. Now the first part is over. Prove that the two tangents can be drawn. Means since it is a quadratic, it is having two values. That's why it will have two slopes. m1 and m2 can be the slopes of those two tangents. You can draw two tangents to that. Right, my dear students. Now, okay, we know that the discriminant of this, right, delta is equal to something like b square minus 4ac. Now b square means okay, k coefficient, like m coefficient, that is now b square, that is k square minus 4 into a is what, m square coefficient, h, c is what, a. This is what the discriminant, k square minus 4ha, right. This now we are going to get according to this, this if it is greater than 0, now this delta is greater than 0 means then you are going to have two tangents which are real and distinct. Okay, and delta equal to 0 means you are going to get two tangents which lie on the parabola, right. Next, delta less than 0 means then you are going to get a point which is inside, then you cannot have tangents for that. Therefore, from this, according to this delta value, we are getting the statement, if it lies outside, delta greater than 0 means two real things. Delta equal to 0 means they lie on the parabola and coincide. When delta less than 0, those are imaginary, means you cannot draw at all the two tangents. Right? By this way, it is giving the total justice to this statement and the way of proving. Right, my dear students, you please observe. Now we have another important result, which is the combined equation of the pair of tangents. The combined equation of the pair of tangents drawn from an external point x1 comma y1 to the parabola y square is equal to 4ax is y square minus 4ax into y1 square minus 4ax1 equal to y1 minus 2a into x plus x1 whole square. That is s into s1 is equal to t square, where s is nothing but the notation is given. Already we discussed this, y square minus 4ax, and s1 is nothing but s1, okay, y1 square minus 4ax1 like this. And t is the equation of tangent. Actually, this is equal to y1 minus 2a times of x plus x1. This is what equation of tangent, and s1 is like this. Right, my dear students? Now we are going to get this. Okay, s1 is equal to t square. How? I am erasing this because the space is not sufficient. See here how we are going to get the combined equation of the pair of tangents. See the proof part of it, if we take, suppose if you take the diagram, my dear students, suppose you have here an external point p x1 comma y1, right? These are the pair of tangents you are drawing, okay? This is some a and this is b like this. And you are having any general point h comma k is any other point on the tangent. H comma k is any other point on the tangent you are having here like this. Therefore, you see, my dear student, a h comma k, like a or this something, some other symbol you can take like that. Any point on the tangent of the parabola, and this is the external point. We know that from that external point we can draw two tangents. Now the equation of PA, what we are going to get here, equation of PA. PA is what? The tangent equation. The equation of PA, actually you know 2 points, right? Then you know that once you know 2 points, you can easily find the equation of the tangent. That is nothing but, you see, y minus y1 is equal to slope of this line. Slope of this line is nothing but y2 minus y1. Okay, if 2 points are given, then you know how to find slope. y2 minus y1 by x2 minus x1, h minus x1 into x minus x1. This is what equation of the tangent PA you are having here. Y minus y1 is equal to k minus y1 into h minus x1 times of x minus x1, right? This is what equation of the tangent we are having. Even if we want, we can even simplify this. Y minus y1 is equal to this total thing, if you multiply, this is x into, right, what we are having here, k minus y1 by h minus x1, like this, right? And that is equal to, now this equation we will simplify this. Let us take y minus y1. y1, if we transfer to the right side, it will become like this. Y is equal to y1 minus x1. This is just we multiplied here. Actually, x into this minus x1 into this. We just multiplied. Now minus, okay, this is y equal to y1 minus x1 times of this plus x times of this. I took here LCM as h minus x1 and simplified. Plus this we have got here. And here minus x1 y1 plus x1 y1 will cancel. Y is equal to y1 h minus k x1 by h minus x1 plus x into k minus y1 by h minus x1. That means y is equal to, you are having x into k minus y1 by h minus x1 plus y1h minus kx1 divided by h minus x1, right? Something like this we have got here, of course. And actually the equation of the tangent, is nothing but y is equal to mx plus a by m, like this. Y is equal to, let us call this as equation number 1 and this as equation number 2. Equation of the tangent in the slope form is y is equal to mx plus a by m. Now comparing equations 1 and 2, right? Comparing equations 1 and 2, right? What we are going to get? Here x coefficient is this and x coefficient is m. Both are representing the equations of the tangents of the same parabola, right? Both are, they are now identical. That's why m is equal to, now we are going to have m is equal to, x coefficient is m here, x coefficient is now here, this is now k minus y1 by h minus x1, like this. This is number 1. And also here you have here a by m, right? A by m is equal to y1h minus kx1 by h minus x1, like this, h minus x1. Now what we do is we eliminate m value, just we multiply here m into a by m, like this. M into a by m is equal to now k minus y1 by h minus x1, this into, right, y1h minus kx1 by h minus x1, like this. M will cancel, like this, right? Once we have got this, now h minus x1 whole square we are having here, of course, h minus x1 whole square, a into, okay, once we cross multiply this, we will get a into h minus x1 whole square is equal to k minus y1 into, right, y1h minus kx1. This is the equation we have got, right? Now this is the equation we have got. Here h comma k is a general point. Now let us replace that by some x comma y, because h comma k is a general point we have taken, that we can replace by x comma y. Then you will be getting that now a into h. H means x minus x1 whole square. This is equal to k. K is nothing but y minus y1, that is into y1h, that is nothing but y1 into x minus k. K is what? yx1. This if we simplify, we will get that y square minus 4ax. This only if you simplify this, this will be equal to S1. S1 is nothing but y1 square minus 4ax1. This is equal to t square. T square means y1 minus 2a times of x plus x1 whole square we are going to get. That means we will get S1 is equal to t square, which is the required combined equation of the pair of tangents to the parabola. In this beautiful and elegant way we have got this result, right? See, my dear students, we have a wonderful definition, that is what? Director circle. The definition of director circle is the locus of the point of intersection of the perpendicular tangents to a conic is known as its director circle. Now the director circle for the parabola is its directrix. You see, my dear students, if you take a parabola like this, you take all the tangents which are perpendicular. Okay, here the angle is 90 degrees. Now you take another tangents, right? This is angle 90 degrees. If you collect all these such points, if you join, you are going to get a line. This is what? The locus of all the points in which the tangents are perpendicular to each other. The pair of tangents are perpendicular to each other to the conic, to this conic. This conic is here parabola. Then if you join all those such points, see here like this, here like this. If you take here also like this, here also like this, right? These are all something like P1, P2, P3, P4. You will get a line, and this is what you call directrix of this parabola or this conic. Directrix, right? Therefore the director circle, once again the definition of that is the locus of the point of intersection of the perpendicular tangents to a conic is known as director circle. Here in this case the director circle is nothing but, right, the director circle of this parabola is the line directrix itself. Okay, my dear students, thank you for watching. Please subscribe to the channel and share to your friends neatly. Okay, you listen and write the concepts neatly. They are very important in your life. Once you listen them here, you will be get through. Okay, even in intermediate you will feel very easy about regarding these concepts. You make use of this video and okay, pause, write the notes, listen carefully and do good. Okay, my dear students, this is what I would like to tell to you. Thank you for watching. Thank you. Don't forget to subscribe. Please share to your friends and like it.